I started to write the steps in the process and then kind of sort of dropped the ball on that. So let's go back and let's write in here, or you make a separate list in your notes, what the steps in the process are for applying the first derivative test, or more specifically, for using that test in addition with checking the endpoints to find absolute extreme values. The first thing you are going to do is to find critical points from f prime. You're going to determine where, for what input values, for x values, f prime equals 0 or is undefined. Or we might say where the graph does not exist. Same thing. Once you do that, the next step in the process is to run the first derivative test on those critical points. You're still going to check on either side of critical points using the first derivative test, even if your function, your derivative, doesn't go to 0 there, even if your first derivative is undefined there, you're still going to plug those in as critical points into this table, and you're still going to test on either side. This just helps you identify where the function could have a max or a min. Both of those do. So you have to test on both sides of those. Once you make your determination by identifying that slopes go from positive to negative or negative to positive, once you make the determination that you have local maxes or mins, the next step in the process is here, check the endpoints. Now, I'm not putting in this process that you need to plug the critical points into the function and find what they are and all that kind of stuff. But by the time you get to the end of your process, you should check critical points from the first derivative, critical points from the endpoints, and the last thing you are going to do is answer the question that was asked. Many times, you're going to get a question that says, at what x values could this function have a max? At what x values did this function have an absolute max and an absolute min? That's saying you can stop before you find the outputs. If it asks at what x values does this happen, then you don't have to find the absolute extreme of values. But if it says find the absolute max, find the absolute min, then you better plug it into your function, make some comparisons, and make a decision of which is the absolute min and which is the absolute max. That's how this is done. So make sure you could apply that process. So one final time, one final example, just to make sure that we've got it all straight. Find the absolute maximum and minimum values of this function on the interval -1 to 2. Step 1, pursue critical points from the first derivative. Pop my constant out front. My power pops down front. Reduce the power by 1. Clean it up a little bit. And in this context, I really want to take that and write that as a fraction. Because what I'm looking for is I'm looking for zeros or where the function is undefined. This is an example where the first derivative, nowhere on this interval does the first derivative equal 0. However, at x equals 0, this derivative function is undefined because I'll get division by 0. This is the one and only critical point that I'm going to get from the first derivative. I'm going to use that in the first derivative test just like I use the critical points that come from where the first derivative equals 0. Going to check test points on either side. Going to plug those values into the derivative function. If I plug a negative value into a cubed root, I'm going to get a negative value out. If I plug a positive value in, I'm going to get a positive value out. F of x has a local min at x equals 0. Is it the minimum value? I don't know. I need to compare the output of the function there with the output of the function at the endpoints. So 3 times 0 to the 2/3 is 0. 3 times negative 1 to the 2/3. I want you to see that this is the cubed root of negative 1 squared. Be very careful about fractional exponents. Negative 1 squared is positive 1. The cubed root of 1 is 1. 3 times 1 is 3. This is 3 times the cubed root of 2 squared. So this is 3 times the cubed root of 4. I don't need to turn that into a decimal approximation to know that if I take 3 and multiply it by 1 versus 3 and multiplying it by a value bigger than 1, that this is the biggest output of those 3. So f of x has an absolute max of 3 times the cube root of 4 and an absolute min of those two values, which is the smallest, 0 is. If you want to graph this function, make sure you set your window to only look at values over that interval, because this is a well-defined function and it will have output values on either side, but you're only concerned about those input values. So only from x equal negative 1 to x equal 2, those are the only candidates where you can find your absolute max and min. So there you have it, the first derivative test. You will be using it a lot. Get ready.